Hello everyone, in this tutorial we'll give you the code introduction and schematic introduction of using ESP8266 module to realize remote control through ONENET platform. This is the schematic diagram. VCC and CHPD of ESP8266 are connected to 3.3 volt of Arduino, RX to the TX of Arduino, TX to the RX of Arduino, and GND is connected to the GND of Arduino. S of EHT11 to pin 3 of Arduino. DIO of digital tube is connected to pin 8 of Arduino. CLK is connected to pin 9 of Arduino. STB to pin 7 of Arduino. Next, we come to the code. Include the header files edp.c and dht11.h, defining a dht11 variable and the port number of dht11. The macro definition API key and device ID can be obtained on ONENET. About how to obtain, you can refer to the previous tutorial. Define the initialization parameters of the serial port. Define a flag bit to indicate that the timing has arrived. Define the port of the digital tube. Define an array that represents the display from 0 to 9. Define an EDP pointer variable. The DOCMDOK function is to determine whether the content of the reply matches. Send command is the initialization function of the digital tube. Define pin 13 as the output in the setup function. Initialize the serial port baud rate to 115,200. Initialize the digital tube. Set the serial port response time. Network ESP8266. When the serial port enters AT, ESP8266 returns OK, which means that the connection is successful. Turn on the LED and set the mode. Set the Wi-Fi account and password. Adeept is your Wi-Fi name. Adeept1315 is your Wi-Fi password. You can replace it according to your Wi-Fi. Then connect to the ONENET TCP interface. Turn on pass-through function, then start sending. Define some variables used by EDP data in the loop function. If EDP is connected, clear the serial port data, then byte device ID and API key. Wait for the reply and save the contents of the reply to a variable. Because the ONENET platform defines a special number that will be returned if a device is successfully connected, we only need to determine whether our data is this special data. If it fails, it will clear the data and wait for the next connection. After the connection is successful, upload the obtained temperature and humidity to ONENET. It mainly depends on packet send function to upload. WD represents the uploading place. WD1 represents the uploaded data. The time flag just defined is incremented by 1 each time. When it is greater than a value, we clear it and update the temperature and humidity. This can be used as a heartbeat. Due to the ONENET platform, the EDP device will be disconnected if without information within 3 minutes. Then we made a heartbeat. Let's start processing the EDP command from ONENET. And this function is to translate the issued EDP command. Save the command and the ID data separately. The command is then passed. If the end of the data is 0, the light is turned off, and if it is 1, the light is turned on. If the data is greater than 1, displayed on the digital tube. When downloading the program, the RxTX port of Arduino cannot be occupied. That is, the RxTX port must be disconnected. And this is all for this time. Thank you for watching.